Hi everyone, welcome to this new tutorial where we are going to build a Sonic themed infinite runner game in JavaScript using the Phaser game framework. In this game, your goal is to collect as many rings as possible while avoiding getting hit by enemies. As the game progresses, it gets faster, which makes it more challenging. Jumping on enemies grants you 10 rings, and jumping on multiple enemies without hitting the ground will grant you a multiplier bonus that depends on how many enemies you jumped in a row. So as I mentioned, for this tutorial, we're going to use the Phaser game framework and specifically the Phaser 4 version, which is nearing release. So we're going to use the release candidate 5 so that this tutorial is relevant in the future, near future, and medium term, hopefully. So before we get started, I would like to talk about the prerequisites you need to have in order to be able to follow this tutorial. So first of all, I assume that you know JavaScript, that you have knowledge of Node, NPM, and a build tool. And in this tutorial, we will be using Vite as the build tool. That you have knowledge of a code editor like VSCode. And that you have knowledge of object-oriented programming. I might here and there talk about a few concepts, but I assume that you have experience with it. So now let's get started with the project setup. So first of all, create a folder, call it however you'd like, and then open it in VS Code. Then open a terminal window in VS Code or outside of it, as you wish, and then run the npm create vite at latest dot command. Now the reason we want the dot at the end of this command is so that Vite will scaffold our project within the folder we're currently in. Now proceed and then select the framework vanilla and the variant JavaScript. Then we're going to install Phaser 4 by using the command npm install phaser at 4.0.0-rc.5. So I want you to have the exact same version as me when following this tutorial so that you will have the same results. And if you want later on, if you're watching this far into the future, you can update gradually to see how things have changed or if they didn't change that much in the end. So now you should see that in your package.json file that the install was successful. So you should see a line where Phaser 4 is there in your dependencies. Now let's get our assets for this game. So in the description of this tutorial, you'll have a link to the final source code. And in that final source code, you can get the assets in the public folder. So I'm just going to copy it over here and let's cover each asset quickly. So we have 3 folders with the fonts, which is just the Mania font. The graphics, we have the chemical-bg, which is our background, the motobug sprite sheet for our enemy, the platforms.png image for our platforms, and the ring sprite sheet under ring.png, and finally the Sonic sprite sheet as sonic.png. So a sprite sheet is just an image containing all the needed frames of animation for a specific character or sprite you want to display in your game. So for now, we haven't imported or done anything yet with them, but we will in a moment. And finally, the last asset type we have is the sounds folder, which contains a few sounds like the destroy.wav, heart.wav. These are going to make sense when we're going to use them, but it's just to make our game more complete and respond to player feedback. So now in the source folder, that src folder, which stands for source, remove everything in it. So Vite created and scaffolded the project and added a bunch of files just as an example to show you how to have a basic web project, but we don't need the code in that. So delete everything in the src folder. And in index.html that already exists at the root of the project, you should add the style tag with the following styles. So basically this margin 0, padding 0 will make sure that the canvas will take the full width of the window and not leave a little gap, which if you don't set both the margin and the padding to 0, this is what will occur. And we're gonna make the background color to black so that we have the standard black bars that will appear if the game is scaled in a certain way, because we want to scale our game while retaining the aspect ratio. So now that we have done this, let's create a main.js or main.js file in the src folder, and in there we're going to import our phaser. So let's write the command import phaser from etc. And then we're going to set our config for our phaser game. This is the root of our project, the root of our phaser project. So the way phaser is configured is that you create a config JavaScript object, and here you can specify the width. Here for our width, we're going to take the width of 1920 and the height of 1080, which is a full HD resolution. Then for the background, we're going to specify a color, which is, I think, bluish kinda. Anyway, just put the colors you see on the screen. It's a hexadecimal code for this. And then, because, you know, colors can be defined either with RGB values, so red, green, and blue. Each can vary between 0 and 255, but here is another notation. Then we have the scale property, which is very important because this is how we make the canvas on which the phaser game will be displayed scale according to its aspect ratio scale, but without losing its aspect ratio, sorry. So in this case, we have the scale property, which takes an object, and here we define the mode and the auto center. So by calling the mode phaser.scale.fit, it will make sure that the canvas will scale according to the window size, while retaining the aspect ratio. While the auto center property here will make sure that the canvas is centered. So if you don't use the auto center property, the canvas will still scale correctly, but will be more at the top of the page instead of being at the center. And finally, we have a scene property, which is going to be an empty array for now. It's where you define your scenes so that your phaser game know which scenes are in your game. So at the end of this config object, let's actually pass it to the phaser, to phaser itself, by instantiating a phaser game. You can do this by calling the new keyword and doing phaser.game and then passing the config. This is how you initiate a canvas or a phaser game, basically. Now, what we're going to do is create a scenes folder within the src folder. And in there, we're going to create a file called game.js. So as a convention for each of our scenes or game objects, we're going to start the file naming convention with a capital letter because they are classes in the end. So the way phaser works is really object-oriented heavy compared to other alternatives like Kplay, where it's not, Kplay doesn't impose on you really a style. But with phaser, if you want to use phaser according to how it's designed, object-oriented with classes is the way to go, it seems. So now in our game.js file, create a class that will extend the phaser scene, will inherit from it. And in that class, so we're going to have a constructor, and this constructor needs to call the constructor of the parent class, which is the scene class from phaser. And this is why we need to call super. And by doing this, phaser allows you to name the scene. And you can do this by passing to that super function the key, the name you want to use for that scene. So by passing an object with a key property and the string you want to use for that scene. So just to summarize, you call the super function to call the constructor of the parent class, which is something needed in phaser. And then we're going to also create the create and update functions, which are going to come handy later. Now that we have our first scene, let's add it to our config so that phaser knows it exists. So in main.js, you can go there, and then in the scene array, you can import at the top of the file first in main.js the game scene, and then pass it in that array. Just to be clear, the order is important here. So the first element of that array is going to be the default scene. So for now it's the game scene, but later on, for this project, it's going to be the game scene, our first scene. Or no, actually, we're going to have a loader class first, a loader scene, to load our assets before moving on to the game scene. But for now, this is our first scene. Finally, now to actually see the canvas, we need to add something to our config. So what we need to add is the parent property. The reason this is important is that we need to tell phaser where to place the canvas in our index.html page. So here you're gonna pass the ID of the div under which we want our game canvas to be placed in. And here it's going to be the game game ID. The ID is going to be the game string, which if we go to our HTML index.html, we can see that we now add this as our div, the ID of our div. So the phaser canvas is going to be placed within that div. Now, to make the canvas distinguishable from the background, let's actually use a different color for the background color. We need to use background color property. So another mistake I did on my part was to specify the background color as just the background key in the config, phaser config. Actually, the name of the property you need to set here is background color. Otherwise, it's not going to work. And here is the new hexadecimal code we need for this. It's going to be a bluish color, so that the difference between the background of our page and the background of the canvas is going to be clearly visible, and you're going to know which end where. So now that basically wraps up our setup, but before starting to work on our game, let's actually add a hello world text to our game just to see that everything works correctly. So to do this, let's go to our game scene, and this is where the create method that we created initially is going to come in handy in our game scene. So the way phaser works is that you create your scene class. You have your constructor, which will run once when the class is first instantiated, and then you have the create method, which will run when we enter that scene. So here, let's create a constant called center pos, which is just going to keep track of the coordinates of the center of our screen. So for example, here, to get the center, you just have access to it by calling this.scale.width. This refers to the scene itself, and it has the scale property by default, which comes from remember, since our game scene inherits from the phaser scene, it has a bunch of properties already made that we can have access to now. And that's why we can do this.scale.width to get access to the width of our canvas. We divide it by 2, and this is going to give us the x coordinate of our canvas. The same logic applies for the y coordinate, but this time with the height. And here I made a mistake. I wrote width instead of height. So let me correct that. And now to create text, to display text, you can simply do this.add.text. So the add method is also accessible now since we have inherited from the phaser scene. And this add method allows you to add multiple different things that we're going to see in this tutorial. But what we want to add to the scene is text. And the text method takes as the first param an x coordinate where to place the text, a y coordinate where to place the text also, and finally a third param where you actually put the text you want displayed. So here we're going to use centerpos.x to have the center coordinate on the x-axis, centerpos.y to have the same coordinate on the y-axis, and a hello world string in capital letters for the text we want to display. Now, actually, there's more than 3 params. So if you want the text to look sharper and not be blurry, or you want to change properties like its font, the font being used, or the size, you can pass a 4th param to the text method, which takes in an object, and here is where you define various properties. And here, let's define the font size property, which allows us to set the size of the text. So here it's going to be 128, and we can also set the resolution of our text so that the text appears much sharper. So here we're going to set it to 4. So now if you look at your window, our browser window, by running the project, so maybe you actually did this but anyway, you can do this by doing npm run dev in the terminal where the folder, the code is located, and then you should have a localhost 573 or 4, depends, which will display your canvas, your game. And here we have a bluish canvas with the text hello world displayed. And that's about it. We have our project set up. Okay, now has come the time to load our assets. To do this, let's create a specific loader scene in our scenes folder. And the reason we're doing the loading logic, the asset loading logic in a specific scene rather than doing it in the game scene itself is that imagine someone plays your game and then goes to the game scene, and then, for example, they die, so they're brought to the game over scene, and then they want to try again, so they're brought again to the game scene. Imagine if the asset loading logic were done in the game scene, then it would rerun every time we go to the game scene, and that would be really not helpful. So for that reason, it's customary to first create a loader scene where we load our assets once when the game is first opened, and then we go to the actual game. So in our scenes folder, create a loader.js file, and in there, create a class that inherits from the phaser scene class. And then here again, let's call the create our constructor, and then call the super function to call the parents constructor. And then here we specify the key we want to use for that scene, which is going to be the name loader. And then in a phaser class, you have also access to the preload method, which we're going to use here. And let's start by loading our sprite sheets. So the first sprite sheet we're going to load is the Sonic sprite sheet. To do this, we can use the load method available on the scene, provided of course by phaser through the scene parent class. And then here, by doing this.load, we also have the sprite sheet method we can use. So let's do this.load.spritesheet. And then the first param is the name you want to use for that sprite sheet to refer to that sprite sheet in your code. The second is going to be the path to find that sprite sheet. And here, since it's in our graphics folder, and one thing about Vite is that everything you put in the public folder will be treated as if they were at the root of the project. So that's why it's /graphics/sonic.png and not /public/graphics/sonic.png. And then the third param is an object where we can specify the frame width and frame height. So this will give to phaser the information it needs to know how to slice up your sprite sheet into individual frames. Now you might be wondering, how did you determine that the frame width of this particular sprite sheet was 32 and the frame height was 44? Well, you can determine this two ways basically. If you are the author of the sprite sheet, so you know this information. Otherwise, you can determine it by just looking at how many frames of your animation you have per row and how many frames you have per column, and then the width and the height of the full image. And then you divide that. So we're going to do the same thing for the motobug, which is the main enemy of the game, the only enemy, by the way. And here the frame width is 48 and the frame height is 30. Now for our platforms image and chemical background, which is the background we're going to use for our game, since these are single images, they're not intended to be sprite sheets, we can simply use the image method to load them instead of the sprite sheet method, which only takes two params, the name you want to use, here platforms and chemical-bg, and the path to each of those assets. Now for audio, it's very similar, just you use the audio method instead. And again, you pass in as the first param the name you want to use, and as the second param the path to those sounds. So now that we have loaded all the assets we need, we actually need to create our animations from those sprite sheet. To do this, we write this logic in the create function of our loader scene, because if we were to do this in the preload function, we aren't sure that the assets are loaded. While because we're doing this in the create function, we know for sure that whatever was executed in the preload function was already executed, because this is how the phaser life cycle works. So here in our create method, we're gonna create our animation by calling the anims property, the create method of the anims property, which is accessible through this.anims.create, and pass to it an object. This object needs to contain a key that you want to use for the animation. Here it's going to be the run animation. Then the frames that compose this animation. And you can determine the frames by calling this.anims.generate frame numbers, because it expects to be given, I think, an array of numbers, which each number representing a frame. And here we don't know this in advance, so we can use the generate frames numbers method. Pass as the first param the sprite sheet we want to use, and as the second param, the starting and end frames. Actually, the generate frame numbers name is, I think, a misnomer, because it's giving back the actual frames, because the number, we know them. It's the start animation is 0, and the end, the start frame, sorry, is 0, and the end frame is 7. How we determine this is that you take your sprite sheet and you start from the top left corner. For each frame, going from the top left corner to the right and then down, etc., it starts at 0. So the frame at the top left corner is 0, and then the one next to it is 2, is 1, sorry, and then the one next to it is 3, etc., etc. This concept of numbering frames starting from 0 is something that is usual in a lot of game frameworks. So here we're basically telling Phaser which frames compose our animation and giving that to the create method as a property of the frames of the object expected by the create function. And now finally, the last property is the frame rate. Here we want the frame rate to be 30 because this is what looked good. Now I forgot to create the jump animation, but we will do it later on. So for now, we have the modo bug-run animation much the same way. So feel free to pause and copy what we need here. And again, you can determine the numbers for the frame by just looking at the images, the sprite sheet themselves, and starting from the top left corner, counting 0, and then progressing to the right by incrementing the number. So now that we have finished creating our animations, loading our assets, it's time to add the loader class to our Phaser game. And we can do this by first going to main.js, importing the loader scene, and then adding it to our scene array. And as the first scene, as the first element of that array, because we want the loader scene to run first before going to the game scene. Now there's one thing left we need to do in our loader scene, is to actually write the logic to switch to the game scene. So this is done in the create function. After we have first in our preload function, which will always run before the create function, it loads our asset in the create function, create our animations, and then we are ready to move on to the game scene. And you can simply move on by doing this.scene.start, and then pass to it the string of the scene, the key basically, of the scene you want to go towards, to transition over to. And here it's the game scene. So if we run the project, you can see that after a while, the assets are loaded, and it can be very quick for you because the assets are already available. They don't do a network call that takes some time. So it might be near instantaneous for some. And then you see the game scene with our hello world text. Now has come the time to actually start working on the game itself. So the first thing that we're going to do is implement the scrolling background, because our game is really reliant on that. So by scrolling background, I mean the city background that you see, which I named chemical-bg in the image file. And of course, the platforms also, the platforms on which Sonic stands also are going to scroll. So to achieve this, we're going to go back to the game class and remove the hello world text and add two class variables, the score and the speed, and also the center pause, which is useful to know where the center of our game is. The reason the score and the speed are going to be class variables is because we are going to need them in the update method. And by doing this.score and this.speed, they're going to be easily accessible from there. So now we also need to do the same thing for the background. So let's create a class variable by doing this.background and call the tile sprite method. And this allows us to display a tile sprite, which is like a sprite, but we can make it scroll within, in place. So the first two params are the position, and the two params that comes after are the position of the coordinates within the image. And the fourth param is the name of the sprite we want to display. Because the way we're going to achieve this scrolling feature, is by scrolling within the image. And now there's a limitation when it comes to tile sprites in Phaser, is that they need to be of a dimension of 2, power of 2. So the reason for that is if your original image is not a power of 2 in its dimensions, it's going to be blurry, and yeah, so it won't scale well. So actually it's not a limitation of Phaser, it seems to be a limitation of WebGL1, which is what Phaser uses. So that explained why the chemical dash background and the platforms are all square images. So now if you look at the result after creating the object, you can see that our tile sprite of the background is at the top left corner of our canvas. That's because we need to change the origin of the sprite. So this is something new in Phaser 4, but in Phaser 3, by default, the origin of a sprite was its top left corner. So if we were to have the same logic, it would actually put the image in the correct place. But it seems that since Phaser 4, things have changed for sprites, is that the origin is now the center. And we need to put it back to the top left corner. And this is achieved by calling the setOrigin method. So actually we need to do two things here. We need to first scale the image twice for it to fill the full canvas. So you can do this by, now that we have our background assigned to the background class variable, then we can do set scale and then pass the number by how much you want to scale it here too. And then you can also use the setOrigin method, and here by passing it 0, it's going to center it at the top left corner, at its top left corner. If you wanted to center it at its center, you would in Phaser 4 not need to call setOrigin at all. In Phaser 3, you would have to do 0.5. So now if you look at the result, you can see that the city background, the chemical zone, that's why it's called chemical. It's from a Sonic game. The second level in Sonic, I think. Sonic 2, or maybe? Yeah, I don't remember. Anyway, now you can see that the background is properly positioned and at the correct size also. So now, let's do the same for the platforms. The same logic applies, but this time around, instead of passing the chemical-bg name, we pass the platform's name and also assign it to a platforms class variable we just create on the fly here. And now we can see that the platform is correctly positioned and at the correct size, because we also need to scale it by 4. And we can do this by calling the set scale and passing the number 4. And of course the setOrigin also to be set to 0 in order for the origin of that platform's sprite to be at its top left corner. So now you might notice that things are a bit blurry. And that's unfortunate, but there is a fix for that. So in our config, you can use the pixel art property and set it to true. If you do so, things are going to look much sharper. However, this is a temporary solution, as the pixel art option doesn't jive well with TTF fonts. And since in our game we're going to use the Mania font and it's a TTF font, you're going to see like visual artifacts, and we're going to have to use another method in order to have a solution that both will make our sprites sharper, scale correctly, and at the same time have our text render correctly as well. So just for your information, how Phaser scales this pixel art for it to be sharp is by using a nearest neighbor, something called a nearest neighbor scaling method that is applied. So now for the actual scrolling of both the background and the platforms, this can be done in the update method of our game class. And here we're going to need to have the delta. So the reason we need a delta, which stands for the time elapsed since the previous frame, is to make our movement frame rate independent. If you were to not use that, you would, for example, if your game runs at the faster frame rate, for example, you're on a more powerful machine, then everything is going to move faster. So a character that will move from left to right will be further along if the machine on which the game runs is more powerful, basically can run at the game at a faster frame rate. And we don't want that. We want it to be the same, be at the same position. And that's why we use delta time to have frame rate independent movement. So here, by using our background and platform class variables, we can scroll within the image, and definitely by setting the tile position, incrementing the tile position x by 0.05 for the background, and multiplying it by delta to make it frame rate independent, and it's going to scroll within the image. And this is a feature that is really handy in Phaser, and it's not available in, for example, Couplet, where you have to manually do the scrolling, infinite scrolling yourself. So just doing this, since it takes the coordinates within the image itself, so there is the coordinate of the image, the sprite, which is in our game world, and it's set at 0, 0. And there's the coordinates, which is represented by tile position x and tile position y, which are the coordinates within the image itself. And because we can increment the tile position x, we can basically move that coordinate, and it results in infinite scrolling. So even if the image is going to move to the left, but it's moving in place. And what comes to the right is the same image, so it repeats itself, a repeating pattern. We apply the same logic for the platforms, but this time around, it's not a fixed speed. It's rather a speed that is going to increase as the game progresses, and it is for now stored in the speed class variable, which is why we're going to use it here by doing this dot speed and multiplying it by delta to make the movement frame rate independent. So now if you look at the result, you should see that you have both the platform and the background that are scrolling indefinitely at different speeds. Now has come the time to add a physics system to our game. In Phaser, you can use the default arcade physics system, which is really handy and appropriate for retro style games like we're doing, where we don't need really like complex physics, and we're gonna need that. So to add it to our game, because it's not there by default, you need to add it to your config in order for you to be able to use it. So here in our config object, we're gonna have the physics property, which is an object, and specify the default physics system we're going to use, and you pass in the string arcade. Then in the same object, you're going to have the arcade property, and here we can define two things: the gravity, which is the gravity of our game, and here you're going to specify the y gravity to be 4,000. This value is what looked good during gameplay, but you can feel free to tweak it after the tutorial if you want to, or during. It doesn't really matter. And the debug property allows us to see the various hitboxes of our physics objects. We don't have any for now, but it's going to come in. You're going to see it later on. So let's create a physics body for the platform on which Sonic will stand. And by the way, I forgot to explain how the game works. It's based on one single illusion, is that actually Sonic is stationary. He never moves to the left. He just is at the same spot and can only jump up or down. Well, actually can only go up or down by jumping. And it's the platforms that move and the enemies that moves toward Sonic. The game is based on this illusion. To create the physics body we're going to need for our platform, we need to create a static body, basically. So a body that doesn't move, is not affected by gravity. And we can achieve this by using the static group method in Phaser. Even though we only have one static body, you can create multiple ones using that method. So here is how we do it. So in our create function, let's create a constant called ground group, which will hold the physics object, the static object. And you can create a static group by calling the static group method, which is under the physics object. Then we're gonna actually have the ground itself. We're gonna set it to a variable, and we're going to we don't need to set it to a class variable here. We could have decided to just have a const or just not have a const, because I don't think we use it later on. You can chain the functions, the methods we're going to call. So basically, you create from the group a specific static body by using the create method and passing it the coordinate of where you want to place it. Then you call the set size method on that static body to set its size. Here is going to be 1920 by 160. So basically the whole width of the screen, of our game screen, canvas. And 160 is basically a size that is big enough. You could have set it to less than that. It doesn't matter in the end. And then we're going to make it, we're going to set the visible to being false, so that the physics object, the static body itself, is not visible, because by default it is visible. You're going to have a kind of a square, and yeah, it's going to be visible. But since, remember, we have the debug options set to true for our physics system in our phaser config, you're going to see that if you look at the result, you can see a little outline, a blue outline around where the static body we just created is positioned. And this is useful for debugging, to see the hitboxes and see if they fit, they are the correct size or not, etc. When you're going to upload this game or publish it, you of course set the debug property to false. So now let's create the logic for Sonic. So create an entities folder, and within create a sonic.js file. Then within, let's create a class called Sonic that will inherit from a phaser sprite, which can be accessed from the phaser sprite class, which is accessible through the phaser.gameObjects.sprite namespace. And then here we're going to have a constructor, and this constructor we're going to pass to it the scene, the current scene in which Sonic is, its x coordinate, its y coordinate, and we're going to pass all this information to the parent class by calling super, which will allow us to be able to use certain methods that later on. Then we're going to set the scale of our Sonic object by 4, so I'm going to scale it 4 times basically, because initially the sprite is too small. Then we're going to add the Sonic game object we were currently creating with this class to the existing scene. Since we have passed the scene to the parent class, we can access it through this.scene, but you could have also accessed it directly by just using the scene name, since it's passed as a param, but just for your information. And then you can add it to the current scene by doing add.existing and then passing the this. The this keyword here represent the class itself, the instance itself, so Sonic in this case. So this is something about Phaser, is that yes, it's the most popular Phaser game framework, but you can see that the API is kind of hard to reason about, and sometimes there are things that don't make a lot of sense, but you just have to learn them if you want to use the framework. So here, then we're going to add Sonic to our physics system as well, because we're going to create a body for it. Well, by doing the this.scene.physics.add.existing, and then passing the current instance, so Sonic itself, we're going to have access to the body variable, class variable, which holds the physics body for Sonic, for the current game object we're creating. And here we can set its mass to 10 to make it heavy enough, I guess, and the size of the hitbox of the physics body, which is our hitbox in this case. So let's set it to 10 by 10, and then let's also play in animation. So since we're creating the Sonic class by inheriting from the sprite class from Phaser, we have access to the play method, which can be used to play animations. And to play an animation, you pass an object to that method with the key of the animation you want to play. And here we're going to have the repeat property set to -1, which is Phaser's way to know that it needs to repeat the animation indefinitely. And here you can see that really this should have been a boolean. Why is it a number, a negative number? So you can see that the API kind of doesn't make a lot of sense in certain cases. This isn't a phaser criticism tutorial. It's actually, let's build stuff with it. Anyway, now if we go back to our game class and make sure to import the Sonic class at the top of the file in game.js, and then we can instantiate our Sonic game object by also assigning it to a class variable. Here I'm going to call it Sonic. So this.Sonic equal new Sonic game object, Sonic instance. We pass this, which is this keyword here represents the scene, since we are in the game class. So this is actually the scene, represents the scene. And then 200 by 750, which is the X and Y coordinates where we want to place Sonic. Now, if you look at the result, you can see that Sonic falls down. So there's still some things we need to set up for the collisions, for the static body of our platforms, to make sure that Sonic lands on it and not pass through it. And the way you do this is in our game scene under the create method, right below where we instantiated the Sonic object, we can call our physics system and call the collider method and pass to it which entities we want to listen for collisions. And here the first entity is Sonic, which we can have access to via this.Sonic, and the second entity is this.Ground, which is our ground. And the third param is the function that will run when this occurs. Just having this, so for now we're going to leave it as an empty function, arrow function, with the comment to do. By just doing this, the physics system seems to understand that, hey, Sonic does not need to pass through shouldn't pass through the static ground physics body. So now if you look at the result, you can see that Sonic now falls down but stands on the platform, but in a weird way. That's because if you have the debug mode activated, you can notice that there's a little square that represents the Sonic physics body, and it's too small. It doesn't really cover the proper dimensions we want it to cover for Sonic. So now if you go back to the Sonic class and where we set the size of the body, instead of having it set to a width of 10 by 10, you can set the width to 22 and the height by 26. This is what looked good. And if you look at the results, you can see that the hitbox is the proper dimension, but Sonic is still offsetted weirdly compared to its physics object, a physics body. Let's use the proper term. So now we need to set the offset itself. To do this, let's add use the set offset method and set it to 5 by 18. And by doing this, the physics body of Sonic and the Sonic sprite will be properly aligned. And now we can see that Sonic actually stands on the platform. Now to make our game more easier on the eyes, easier for the player to understand, let's reduce actually the background's opacity so that the game is more legible. So here you can do this by going back to the game class and where we had the this.background, and then add a call to the set alpha method, which takes a value between 0 and 1. And here we're going to set 0.8. So the bigger the value here, the more clear the image gets, with the maximum being 1. And the closer to 0, the closer it is, the opacity reduces. Now you can see there is a bluish tint, it seems, on the background image, because remember, originally we set the background to a bluish color. So now let's set it back to something like black. So again, in our config in main.js, set the background color to being #000000, which corresponds to the hexadecimal code for black, for the color black. Let's also, by the same token, disable the debug outline. So the debug mode, by setting the debug property in the config to false. And now let's write the logic for Sonic to jump. So in our game class, let's keep this simple. Let's create a disposable function, just call it jump logic, and it's an arrow function, and we're going to make Sonic jump in it. And then this is just to show you how to handle input. And right below, you can handle input by calling this.input.keyboard.on. And here as the first param is the string that determines what key and what action to listen on. And here it's going to be key down dash space. And the second param is going to be the function to run in that case when that action occurs, when the space is key down, so when we hold down the space key. And here we're going to pass in our jump logic function we just created. We're going to do the same thing with another way to handle input, but this time for clicking. We're going to do this.input.on, and then pointer down is going to be the event on which to listen on. And again, call the jump logic, pass the jump logic method, function, sorry, here. We don't call the method here. We just pass the definition of it, and we let Phaser call it. That's why we don't use the parentheses. We don't make a call to that function. So now let's go to our sonic.js class. So our Sonic class. Let's create a class variable called jump velocity, and let's set it to minus 2100, which is the value that seemed correct. Let's also create a jump method, which is going to hold the logic for making Sonic actually jump. And then here, we're going to have an if statement that checks if set velocity y is available in the Sonic physics body, which is accessible with this.body. And if it's the case, then we will set the velocity y. The only reason I have this if statement here is because if you work within VSCode, TypeScript will complain. You're going to have some TypeScript IntelliSense that will tell you, hey, we're not sure that set velocity y is actually in this.body, so yeah, you should handle this. So just to make it shut up, but if you use vanilla JavaScript, you shouldn't have any issues, actual issues, real issues, like when running the game, if you don't have this if statement. But anyway, within this if statement, call the set velocity y method on the body and set it to being the value of the jump velocity. This will actually make Sonic jump. So now if you go back to the game class where we wrote this simple function, jump logic, the only reason we wrote it here is just to be able to, instead of having to copy paste the same jump logic 2 times for the keyboard input listener and the mouse click listener, actually pointer down listener, so it also works for mobile. We just do it once here. So within the jump logic function, call this.sonic.jump, which is the method that actually holds the jump logic for Sonic. And if you look at the result, you can see that Sonic actually jumps. But we still need to set the correct animation. So now if you go back to the Sonic class, and within the jump method and within our if statement where we check for the set velocity y property if it's available in the body, right below where we set the velocity y for our Sonic's body, we're going to call a method that allows us to have a delayed call. So let's say we're going to have 100 milliseconds before we actually switch to the jump animation. Okay, so I don't remember exactly why I used the delayed call here. For now, keep it, and then at the end of the tutorial, try removing it and see if there's any difference. Here we're going to set the animation to being the jump animation and to repeat indefinitely. And now I realized that we haven't created the jump animation, so let's go back to our loader class, and in there let's create the animation for it. So we're gonna use the key jump and then generate the frame numbers from our sprite sheet, which corresponds to frames 8 to 15, and let's have a frame rate of 60. The frame rate of 60 is what looked good when Sonic is curving into a ball. So these are all values I deducted by just playtesting my own game. And now you can see that Sonic actually jumps. However, you can notice also that when Sonic lands, he still stays in the same jump animation. We don't want that. We want Sonic to go back to the run animation after hitting the ground. To do this, let's go to the game class, and within the collider logic, we're just going to have an if statement. So the collider logic we wrote previously, which checks for listens on collisions between Sonic and the ground. In the function that is passed as the third param, we're going to have an if statement that is going to first check if Sonic is blocked down. So this Sonic.body.blocked down. Blocked down means there is a collision from the bottom of the physics body of Sonic. If that's the case, and the animation, the current animation is not the run animation, so you can access this by, you can know this by using this.sonic.anims.currentAnim.key. Then only in this case we play the run animation, and we also let it loop indefinitely by having repeat set to -1. So now if you go back to the game, you should see Sonic returning to the run animation after hitting the ground. Okay, so now that we have Sonic that can jump, let's add enemies. So in our entities folder, create a new file called motobug.js. And much like Sonic, we're going to have a class called motobug that inherits from the phaser sprite game object class. Here in our constructor, this time around, we're going to have the scene as the first param, but the position as the second param, and it's going to be a vector too. I want to show you that you don't have to necessarily pass pos x, pos y in the constructor. You can also use a data structure created available from Phaser that allows you to create vector2s, which contains both the x and y coordinate at once. So here we pass this to the super constructor, to the parents constructor by calling super. Then we're going to set the scale of our motobug to being 4 for it to look nice. We're going to add it to the scene using the existing method. We're going to add it to the physics system by creating, so this will create a physics body for our motobug by using existing physics.add.existing. We're going to set the size of the hitbox of the physics body by calling the setSize method and setting it to 32 by 31. We're going to set the offset to being 0 by 0 this time around. I don't think actually you need to set the offset here in this case. If it's 0, 0, might not need this line. And then we're going to set allow gravity to being false. Using this method, our game object will not be subjected to gravity because in the end, anyway, the motobug just moves from left to right, actually from right to left. And then we play the motobug-run animation repeatedly, so indefinitely, by calling the play method. Now we're going to also create a remove if offscreen method, but actually I recommend you don't do this because later on I'm going to realize that this is not really necessary. You're going to just write this logic in our game scene. So now let's write the logic to spawn those motobugs periodically. So every once in a while we spawn a few, and yeah, so this will add some challenge to the game. So in our game scene, in game.js, under our create method, let's create a group. So this is just a group of game objects, and we're going to store it, assign it to a motobugs class variable. And we're going to have a spawn obstacle periodically function. And in that function, we're going to have a delayed call, which will run between every 500 to 1,500 milliseconds. You can have this nice between function or method available here because Phaser also has a math module. And then once this elapse, once the delayed call is finished, we call the same function. So it's a recursive function. It calls itself. So that means the first iteration is going to take a value between 500 and 1,500, and then the next iteration, next call, it's going to take another different value, etc. So it's going to add a bit of variety and randomness to our game. Now let's also just right above the spawn obstacle periodically function we just create a spawn motobugs function, which its goal is going to add to the motobugs group a new motobug. So we're going to import our class, motobug class, at the top of the file, call the motobug, instantiate the motobug game object, pass this as the first param, which is the scene, and for the coordinates for the position, we can create a vector2 by using the Phaser's math module by doing new phaser.math.vector2, and then here the coordinates we're going to use is 1950 by 780. And the reason we're doing this is so that the motobug is just outside of the canvas at the right, and that way it's going to seem that the motobug was already going towards the player. It's gonna not just pop. So yeah, so to give the illusion that the motobugs are coming from the right rather than just popping on in the game canvas directly. And now let's call our spawn motobugs function within the spawn obstacles periodically. So we first spawn a motobug and then have a delayed call that determines when we're going to call the spawn obstacle periodically the function again. This is just temporary because we're going to have a function that is going to determine when to spawn a motobug or when to spawn a ring. So now let's write the logic, the collision logic between, or set it up between Sonic basically and the motobugs. We can do this by much the same way we did for the ground, by using the collider method and then passing as the first param the Sonic game object and as the second param the group, the motobugs group. So, and then we can have as the third param the function that will run, and in that case this function will provide two params. The first param is the Sonic game object that is colliding with the other, and the second param, which is the most important, is the specific motobug that is colliding with Sonic. As for the first one, it's not really necessary. We're going to replace it by just using an underscore, which is the convention in JavaScript when you don't want to use a param that is provided. Now let's have our motobug update logic so that we can see the motobug sliding from right to left, moving basically. So in our update method of our game class, we're just going to iterate through all the motobugs, which is accessible through the children property of the motobugs group. And for each of them, we're going to decrement, that's the proper term, its value, its x coordinate by 6, which is going to act as our speed boost multiplied by the speed of the game and by delta to make this movement frame rate independent, since we are in our update loop. And now to see everything in action, just before we can see everything in action, we need to actually call the spawn obstacles periodically function once in our create method in our game class. Now if I run the game, you can see that motobugs are moving from right to left to where Sonic is. So now let's create rings for Sonic to collect. In much the same way we did with motobugs, create a ring.js file in the entities folder and create a class called ring that also inherits from the sprite phaser game object. Then much the same way we set the scale to 4. Here I forgot to call the super function here. So it's not going to work. I'm going to correct this later on, but add it yourself. So you do super and then as the first param scene, second param pause.x, pause.y. So now here we're going to add the ring game object to the scene by using the existing scene.add.existing method. We add it to the physics system, which will create a physics body for it, much the same way, but this time we're using scene.physics.add.existing. Then we set the size of the body, we set the offset, and we set if we want to allow gravity, in this case, no. So we're going to have false in this case. And then we're going to play the ring spin animation repeatedly. Now, in much the same way, in our game.js file, we're going to create a group for the rings. We're going to have a spawn rings method that just will use the add method to the rings group to add a new ring to it. So make sure to import the ring class at the top of the file and to pass this as the first param and a vector2, which is going to be the same position, by doing new phaser.math.vector2 1950 by 780. And in much the same way, we're going to have our collision logic by setting up the collider method for it between Sonic and the rings. And in much the same way, we don't need the first param of the function that is going to run when this occurs. So you can use a underscore here. Now let's replace spawn motobug in spawn obstacles periodically by creating a spawners constant, which is going to be an array that contains both the function definition for spawn motobugs and spawn rings, and a constant called spawner weights, which determines the frequency, the probability basically, of each of those spawners to be called. And for the motobugs, let's put it 60% of the time, so let's use 0.60 Yeah, 0.6. And for rings, they're going to appear 40% of the time, so let's have 0.4. And now we're going to create a utils file at the root, but still within the source, not at the root of the project, but within the source src folder. And in there, we're going to have a function called select spawner, and it takes in the spawners and the spawner weights. And it's first, we're going to have a constant that is a random value between 0 and 1. And then we're going to iterate through the spawner's length, which is 2 in our case. And now we're going to add a sum here. And if this sum is inferior to the random value, that means that the spawner at the current index is the one we're going to pick. I might think this is a bit strange, so let me explain how this works. So a motobug occurs 60% of the time, so 0.6 is going to be its weight. A ring occurs 40% of the time, so the weight is going to be 0.4. If you add those two together, it's 1. Now, for example, if random value, which can vary between 0 and 1, falls on 0.5, after the first iteration of our for loop, we're going to have the sum being equal to 0.6 because it was 0 initially, and now 0.6 is the first element of the array, the spawner's weight array. And in our particular case, the random value is inferior to our sum, which is 0.6. The random value is 0.5. That means that the sum, you can view the sum as a range, basically. And the motobug range is from 0 to 0.6. That's why, since the point, the random value, falls under that range, then the motobug spawner is going to be the one that is going to be picked. And this is how we determine that a motobug should be spawned. Now let's have another example. Let's say the random value is 0.7. So it still can only still be between 0 and 1. So after the first iteration of our for loop, our sum value is going to be inferior to the random value. So the random value is superior to the sum. So that means that the point, the random value, falls outside of the range and outside of the motobug range, which covers from 0 to 0.6 in our case here. So after the second iteration of the for loop, we have now the weight of the ring, which is 0.4, and now the sum is going to be 0.6 plus 0.4, which is going to be 1. So it covers the full range of possible values. But however, since now the random value is inferior to sum, that means something needs to get picked, and the ring range in our case is from 0.6 to 1. And because remember, the motobug range was from 0 to 0.6, and now because our ring range is from 0.6 to 1, that means that this range is of a value of 0.4, and the point falls within that range, that means the ring is the one getting picked. So you might be wondering, if the weights array was ordered differently or had more elements, would the logic need to change? The answer is no, because you can view each weight as having its own area on which the random value could fall on. So the order doesn't really matter, as the area size for each element remains the same. So now let's import our select spawner from utils.js to game.js. And in there, let's call it, let's first create a constant, chosen spawner, and then let's pass to it select spawner. Let's assign to it the select spawner call, which takes the spawners as the first param and the spawner weights as the second param. And then we call the chosen spawner, because you remember the select spawner returns it. Return the selected spawner we want to call. And this will determine which either motobugs or rings do we spawn in that iteration of the spawn obstacle periodically call. So now that we are done with this, let's add the ring movement logic. So in much the same way we did with the motobugs, we're going to do the same thing in the update loop of our game scene. So we're going to iterate through all the rings in the rings.children property, which is available on the rings group. And then for each of them, we're going to decrement the x position by doing -= 4 times this.speed time delta, which is going to make the ring move from right to left. Now if I run the game, you're gonna see that there is an error, and that's because I forgot to call the super constructor before in the ring class. So now if I add it here, and you can see that the rings properly spawn and motobugs as well. So now has come the time to load fonts. So font loading is a bit different from other assets, especially when it is a TTF font rather than a bitmap font, which is basically a sprite sheet of all the individual characters you need. Anyway, so to do this, let's go into our loader scene and let's create an async method called load font. It takes the name and the URL. And then we use the JavaScript font face class and instantiate it here and set a name and the URL for it, which is a string in parentheses, and then the URL for that font. This is the way you can load a font in vanilla JavaScript through code only, because this is usually done through the CSS. And now we call the load method on that font face object. And then if the loaded font is available, then we're going to add it to our document. So the actual page of our game. Otherwise, we're going to throw an error. And here I made a mistake. You should have a return statement in the if statement right below document.fonts.add. And document name here is something from JavaScript that is globally available. So now we're going to call this load font method still within the loader class, but at the end of our create method, but above where we switch the scene to the game scene. And here you can see that we're trying to use await, but we need to use the async keyword, add the async keyword to the create method for this to work. And here the font path is going to be font/mania.ttf and the name is going to be mania. So in the game scene, we're going to create a text object and store it, assign it to a score text class variable. And here, much like I shown you earlier how to render text, you use the text method and pass the coordinates of where you want to place the text, and then the text itself, and then finally an object optionally that you can use to specify which font you want to use, the resolution, and the font size, for example. The resolution is to make the text sharper, the font size is, as the name implies, for the font size, and the font is the specific font we want to use. Since we loaded the Mania font with the name Mania in our loader function, loader class, sorry, then we can use the Mania name here. So here I'm going to realize that in fact there's a mistake in my load font method in the loader class, and we needed to add the return statement. But now if you run the game, you're going to see that the text is too small. And that's because I made another mistake. It's not just font, the property you need in the game class, it's font family. And now you can see that the correct text appears. Now you can see, if you have a sharp eye or on a big monitor, that the score text will have some artifacts around. And that's because we were using the pixel art option. Now the pixel art option would have been still useful to use if you used a bitmap font, which is otherwise known as a sprite font, where each character of the font is an actual sprite. So in that case, you can just use the pixel art option and call it a day. However, because we were using a TTF font, we need to change our way of doing things and not use that pixel art option. So what we're going to do instead is we're going to scale each, set a filter to each of the sprites we have to use the nearest filtering method, something that the pixel art option does under the hood, but applies it to everything instead of just the sprites. And we want to just apply this to sprites. So in the loader function class, I don't know why I keep saying function. In our create method, let's call this .textures, which is how you access the textures that were loaded. You get the Sonic sprite, and then you set the filter to a phaser textures filter mode nearest. Do the same thing for the motobug, the ring, the platforms, the chemical background, and we're set. So now I want to mention this is that in the code, I bumped the text resolution to 8 instead of 4, but you should keep it at 4 in the end, because later on we're going to have some problems where text just disappear instead of rendering when the resolution is too high. So this is something that will come up later. So now let's add the how to play text as well in much the same way. And this time around, I'm going to set the origin at the center, because one thing I want to mention is that while for sprite in Phaser 4, it seems that the origin is already set at the center by default, for text it isn't, and we don't want to. Just in this specific case, we want to actually center the origin of the text for the press space, click, touch to jump message that appears before the game starts. So now if we run the game, you can see that you have this message appearing. Now you can see that there's a lot of repeating logic. We set the same font family, the same resolution. So what if we just created a mania text config? So let's create a constants.js file and then create a constant called mania text config. We set it as an object with the font family set to mania, the color set to white for now, and the resolution set to 8. But as I mentioned, keep this to 4 instead. So now we can spread this config, so import it in game.js and then spread it where we used to have it in our different text objects so that it applies here, and then we save a few lines of code. And that's it. That's all the logic we need to basically render the correct font. All right, so now let's make a progress bar that will be displayed in the loader scene as we load the assets. I think it's best to have something like that than just a black space, a black void, because sometimes, let's say it takes some time to load the assets, a player could think that the game just has crashed or something. So in our preload method, in our loader class, let's create a constant holding the width of our canvas, another constant for the height of our canvas, so screen width and screen height. Let's have a progress bar constant that will hold a graphics, so you can do this by creating the graphic with this.add.graphics, and then we have access to this load on event listener progress, which is the event we want to listen on, and we're going to run the following function, and it provides us with a value. It provides a value to that function as a param, which tells us the percentage, like the actual, the progress of the loading, the asset loading. So here we're going to have our progress bar, we're going to clear it, then we're going to fill it. So here it's just a rectangle. Well, actually it's some graphic of some kind. So we clear every time so that it updates the screen. So remember, every frame we display something, and we need to clear whatever was displayed previously of the progress bar before we can just rebuild the progress bar with the same color but different size. Otherwise, it's just gonna stay within the scene. I think in our particular case, it doesn't matter. I think you could have just commented out the progress bar .clear code here, because anyway, the progress bar fills up and isn't moving from one place to another. Because if it were moving, then you want to delete the previous rendering at the previous position. Otherwise, it seems like an outline that is moving around. But in our case, it's exactly what we want. Anyway, for the progress bar, we're going to have a fill style, set the color to it. Here it's mandatory to use the hex form of the color. So here it's 0xFFFFFF 6 times is the white color, and 1 is the opacity, so the alpha, and we're going to set it to full opacity, so it's fully visible. Then we're going to have the fill rect to draw a rectangle. So this is similar to using the canvas API in JavaScript, because we don't have access to a lot of the things we have access to in Phaser when we are in the preload state. So for fill rect, the params means the following. So the first param is the x coordinate, the second param is the y coordinate. The third param is the width, and here we multiply it by the screen width multiplied by the value, which is going to give us different values according to how far we are in loading the assets. and then the height is the last param. Now if you run your game, you can see a white bar progressively growing, and depending on your internet speed, it's going to be near instantaneous for some people, or it's going to take some time. So now what we want to do is to destroy the how to play text once the player jumps for the first time after the game starts. So how we're going to do this is in our jump logic function in our game class. We just check if the how to play text game object exists, and if it's the case, we're going to destroy it. And that's it, like that. When the player presses the space key or clicks or touch, the text telling them to do so will disappear because it no longer serves a purpose. Now it's time to write collision logic. So for now, we're going to do this for the rings. When the rings collide with Sonic, we want to destroy the ring. So let's do this in our handler, collider handler for this particular case. So in that handler, we are going to just call the ring.destroy method. Remember, the ring passed as a param to the function here is the specific ring that is colliding with Sonic. Then we're going to increment the score by 1. And then we're going to set the score text using the setText method to display the updated score. And now you can see if I play the game, when I collide with the ring, the score updates. Now, let's do the collider logic with motobugs this time around. So when we collide with a motobug, we're going to have an if statement that first tells us if Sonic is on the ground. And we can do this by having access to its body and checking if the blocked down properties is true. Here we're going to write the logic for that, the game over logic later on, because if Sonic is grounded and they collide with a motobug, that means it's game over. That's why we have this if statement here. But we return, we're going to return after that in that case, when we handle this case. However, if it's not the case, well, that means that Sonic has destroyed a motobug by jumping on it. And we're going to call motobug.destroy to destroy the specific motobug that has collided with Sonic. Now if we check the result, you can see that when I jump on a motobug, it is destroyed. Now let's add the scoring logic, but before that, we need to go back to the Sonic class and add 2 properties, the combo multiplier and the isDead class variables. The first one is to know if we have a bonus multiplier to grant when Sonic jumps on multiple enemies consecutively without hitting the ground. And the isDead class variable is useful to know if Sonic is dead or not. So back to the collider handler for the collisions between Sonic and the motobug. We're going to specify a constant called base score, set to 10 initially. Then we're going to increment the combo multiplier when Sonic collides with a motobug, and it's not a game over situation. Now if the combo multiplier is equal to 1, then the multiplier text will be displayed, and for that text we're going to just display plus the base score. Now however, we're going to have an else statement, and if the multiplier text, that means that the combo multiplier is more than 1, that means we need to display instead a multiplication rather than a specific score. I thought this visual information would be much clearer to the player rather than seeing, let's say, 20 or 30 and they don't know how they acquired this. So having an x times the multiplier makes it more clear to the player what is happening. And then after that, the if statement we're gonna increment the score depending on the base score multiplied by the combo multiplier. If the combo multiplier was just 1, it's going to be just the base score, otherwise it's going to be the multiplication of it. And this is going to update the score, and then we're going to update the text that displays the score. However, in the end, instead of having the combo multiplier as a class variable of the Sonic object, let's place it in our game scene. So I'm going to just create a variable in the create method called combo multiplier and set it to 1 Actually, should be set to 0 because anyway, we increment it in the collision handler. So that's why it should be 0 instead of 1. So if we go back to the handler, we now replace where we had this.sonic.combo multiplier with just combo multiplier plus equal 1, and everywhere where sonic this.sonic.combo multiplier was used, just replace it with just combo multiplier. Now at the end of our handling logic for the collisions between Sonic and the Motobug, we're going to have a delayed call of 700 millisecond, which will reset the multiplier text to being an empty string, because we don't want to display the text forever, you know. We want it to disappear again. It's a temporary text that appears near Sonic when they move. So if you saw the gameplay earlier, it's the yellowish text that displays every time you collide with a ring or you collide with you jump on a Motobug. To actually set the position of the multiplier text, we need to do this in the update loop of our game scene, and by calling the setPosition method and setting the position to being relative to Sonic. In our case, it's this.sonic.x plus 70 on the x-axis and this.sonic.y minus 100. Just to clarify, in game frameworks in general, usually the coordinate system is inversed. The further you go down on the canvas, the higher the value of y is. The further you go to the right, the further the value of x is. Now there's an issue here because I was writing this multiplier text, etc., but we haven't defined it. So in the create function, let's go back and define this multiplier text using the text method. Initially it's empty. We're going to use the mania text config. We're going to set the font size to 85, and we're going to set the color to FFFF00. Don't forget the hashtag at the front. And you might be wondering, hey, isn't the color already defined in the mania text config? The answer is yes, but the way objects work in JavaScript is that the color property we define here will override the color property within the mania text config object. Anyway, so now you can see, if I check the result, that the multiplier text displays when we stomp on a Motobug, but its value never resets to 1 when Sonic hits the ground. We need to fix this. So we need to reset the value of the combo multiplier somehow. And also, not only that, we also need to give a automatic jump to Sonic when they stomp on a Motobug. So back in the logic, the collider logic between the Sonic and the ground, just where we play the run animation, right below, set the combo multiplier back to 0. Now if you check the result, you can see that the combo multiplier does reset, because now we have plus 10 every time we jump on a Motobug and hit the ground instead of x2, x3, times 3, times 2, etc., which is only reserved for when Sonic continually jumps on enemies without hitting the ground. So now has come the time to do the logic to force Sonic to jump again when stomping a Motobug. And we can achieve this by going to the Sonic class, and in there let's create a param called forceAJump, which is going to be a boolean that we're going to pass to the jump method if we want to force Sonic to jump. And we're going to have an if statement that is going to check to make sure that two conditions are not true. That Sonic is grounded by using body.block.down, and that the forceAJump param is not true. If those two conditions are true, that means we do not want to jump, basically allow jumping. So now if we go back to the create method in the game class, and below in the collider logic between Sonic and the Motobugs, right below where we set the score and before the delayed call of 700 milliseconds, we can call this.sonic.jump and pass the true boolean. And now everything should work. And now if you play the game, you can jump on enemies, etc. So now has come the time to write the logic for destroying Motobugs and rings that go out of the screen. So here we're going to really take it simple. You could have decided to implement an object pool where you reuse Motobugs that go out of the screen instead of having to create new objects. And this is probably the proper way to do it, actually. But for our game, since it's very simple, we have very few Motobugs at once, then we're just going to manually just destroy them when they go out of the screen. And this can be simply done by having an if statement in our for loop in our update method of our game class, where we just check if the motobug.x position is inferior to 0. If it's the case, then we destroy the motobug and we continue our iteration of the for loop to check for other motobugs in the motobugs group. And we do the exact same thing for rings. So now here in the footage, I will remove if offscreen methods from both the ring and the motobug classes. Now you shouldn't have to do this because I already told you in advance to not do this, to not add them in the first place. And so now if you test the game, you should see that everything works correctly, and we are now ready to move on to writing the game over logic. In our collider handling logic between Sonic and the motobugs, in our if statement where we check if Sonic is grounded, we're gonna switch over to the game over scene by passing the string game over. We don't have this scene defined yet. So let's create it. In the scenes folder, let's create a game over class that extends and it inherits from a phaser scene. I'm gonna call the super constructor and pass the key game over, which is what we want to use to name the scene. Then we're gonna add the game over scene to our phaser config. Make sure to import it and add it to the scene array. And now if we look at our game, when Sonic collides with an enemy, the screen goes black. That's because we're transitioning over to the game over scene, which is now empty for now. So let's work on adding something there. So in the create method of our game over class, let's add some text at position 0, 0, and let's just say this is the game over screen. So now if you play, you can see that when you die, you have this message appearing at the top left corner of the canvas. So now what we want to do is we want to display the score in the game over scene. To do this, Phaser allows us to share data between scenes by using something called the registry. So in our game class, where we have the Sonic, the game over logic in our collider handler between Sonic and the motobugs, we can use this.registry and then set a particular key. So here the score, I'm going to call it score and pass to it the actual score. Now in our game over class, we can define a constant called current score in our create method and use this.registry.get and then the name of the key score that we set in our game scene. And this is how we can have get the current score. And then we can display it using the text function at the font size 128. Now, if I play the game for a bit, you can see the score is displayed in the game over scene now. So before we continue, let's make a small adjustment to how enemies are spawned. So instead of immediately spawning enemies when the game scene starts, we're going to have a delayed call of 1000 milliseconds before calling spawn obstacles periodically for the first time. This is just to give some breathing room to the player to just read the text telling them how to play the game. Now, one other thing we need to do in the game scene is to increase the game's speed. Let's create a function again in the create method of the game scene, call it increase game speed, and this we just want to have a ceiling to how fast the game can go, otherwise it becomes unplayable. So we're going to have an if statement with this speed that checks first if this speed is superior to the max speed, and then we're going to define this max speed constant at the top of our create function, and let's set it to 0.7. And then in our increased game speed function, let's finish this if statement. So if this speed is superior to the max speed, then we return early. Otherwise, we increment the speed by 0.02. This value felt good when playtesting my game. And then we're going to have a delayed call again between 1000 to 2000 milliseconds to determine when to call increase game speed again. Now you could have decided to have just a constant, you increase the speed every 1000 milliseconds, etc. I just wanted to add some variety. That's why I have a between call here between 1000 to 2000 milliseconds. And then we're going to call the same function. So it calls itself, and we're going to call it once first in the create method right below. Now, if you try the game, you can see that we're getting closer to the final product. The game gets progressively faster, and when Sonic dies, we see his current score in the game over scene. So now, to make the game more approachable, let's add a speed boost to the motobug that will reduce when the game gets to a higher speed. So here in our update logic, we have let's create a constant called speed boost. And then if the speed of the game is inferior to 0.4, we set it to 6, otherwise to 5. And then we use that speed boost in our motobug movement logic. Now, the reason I do this is that at first we want the speed boost to be 6 so that it really is obvious that the motobug is moving on the platforms and is moving to the right. Since the motobug with a speed boost of 6 moves faster than the platforms scroll, it's going to get much harder, basically, for the player. So that's why this is a sneaky way to make the game easier at higher speeds. So now let's go back to the game over scene and let's store the best score using local storage. So here I'm going to create in our create method of our game over scene is a best score data constant that is going to get the item of a best dash score key. We haven't defined this yet, but we're going to do it in an instant. So now we're going to have a variable called best score, which is going to parse the best score data constant here and check if the value property is defined. Otherwise, set it to 0. And then here in our if statement, if the best score is inferior to the score, then we're going to, in local storage, set the item best dash score to be a JSON that is then an object that is then stringified with the value property set to the score, the current score. And then the best score becomes the current score. Now in our constants.js, let's create a ranks constant that is going to hold the various ranks the player can achieve. So depending on their score, we're going to assign to them a rank. So if we go back to the game over scene, let's define two variables, one for the current rank and one for the best rank. And let's put both at F initially, and then we're going to iterate through the ranks object. Make sure to import it in the game over scene first, and then we're going to check the grade, and then check the value related to the grade by storing it in the value constant that we just create. If the value is inferior to the score, we set the current rank to be of that grade. And if the value is inferior to the best score, we set the best rank to that grade as well. So as we iterate through, we set different grades up until we can't do this anymore, because now the value related to a grade is higher than the score. So we won't be able to move to the next tier. And that's how we determine the current rank and the best rank to assign in the game over scene. Now you could have said that we should maybe just have stored the best rank already instead of having to recompute it every time, but it doesn't really matter in our scale since the game is very small, and yeah, it doesn't take much computing power to do this. And there's a limited set of ranks anyway. So now in our create method, let's display some game over text. Let's first create a constant to hold the center position, which will allow us to place our text, game over text, etc. according to the in an easier fashion, because we want the game over text to be centered but at the top. And then here it's basically the same thing, font family, etc. I'm going to import the Mania text config. This time around we also want to have a delayed call of 1000 milliseconds and display after 1000 milliseconds the press space, click, touch, etc. to play the game again, and also to allow the player to play the game again only after 1 millisecond. This is to avoid after 1000 milliseconds, sorry. This is to avoid the situation where the player enters the game over screen and immediately by reflex press the space key and the game starts immediately. So to avoid this, we have a delay of 1000 milliseconds before they can do any actions. And now using the same structure we had for jump logic, for the jump logic function, we're going to have a restart game function that goes to the scene, the game scene. And then we have our input handlers for the keyboard and for the mouse and the touch, all calling the same restart game function that moves the game to the game scene. And now we also need to center our press space / click / touch to play again by using set origin 0.5, by the way. Now here in the footage, I will realize that, hey, the press space the message does not appear. Now it turns out that the reason for this is because we set the resolution of the text to 8, and I told you about this earlier, and that's why this is very strange. I don't know why exactly, but putting it back to 4 fixed the issue. So now if you go to if you check the result, when you play the game, you're gonna have game over, and then after 1000 milliseconds, so a second, you have the press, space, click, touch to play again message, and then you can press the key, for example, the space key, and the game will restart. Let's add a score box that displays the current rank and the best rank. So define a method on the game over class called add score. Here I made a mistake. I initially wrote it as add score text, but it should be add score box. It takes the position X, position Y, and the rank text, and then it creates a box as a rectangle with which is black and with a width of 500 and a height of 500. Then we set the origin to 0.5 so that it is centered. It is rendered from the center, from its own center. We set the stroke style to 4 and 0xFFFF. This is the hexadecimal code we need to have white outline around the rectangle. And then we're going to have a rank itself as text, which is going to be displayed relative to the box and is also going to be centered. So it's going to take the position of the box, and since the box is also centered on itself, that means the text is going to be displayed at its center, and we need to center the rank text itself so that it is properly centered. Now let's use that method we just created, add score box, and let's add those 2 boxes with the following positions and ranks, and then pass to it the current rank and the best rank. If we try playing the game now, and after playing some time, you can see that when I enter the game over screen, I have my rank, my current rank on the left, and the best rank I ever did to the right. So now let's go back to our game over scene, and let's have another method called add score text. This is to display the current score and the best score on top of the rank boxes for each. So here nothing new, no new concepts. It's basically the same thing as we are used to by now for text rendering. Let's add them on top of where we add the score box. Now if we test the game, you'll notice that the text is a bit too big. So let's make the fonts smaller. So 64 sounds good. And now if we play the game and go to the game over scene, we can see that the text is now properly displayed. And now has come the time to add sounds to our game. In our Sonic class, let's add the jump sound, which you can do using the scene.sound.add, the name of the sound, which we have already imported in our loaded in our loader class, and the volume you can specify. Here 0.5 sounds good. Then you can use that sound, this jump sound that I declared as a variable of the scene. Actually, you know what? You don't need this to be as a property of the scene. You can just have it directly as a property of a class variable of the Sonic class itself, and then we use it in our jump method. So in our jump method, within the if statement, we have another if statement. We check if the jump sound is playing. If it's not playing, then we play it. So now if you run the game, every time Sonic jumps, we hear the jump sound. Let's add other sounds. So where we collect rings in our game scene, we're going to play the ring sound. You can play immediately without having to add the sound. So adding the sound is useful when you want to reuse it elsewhere. Here we just want to play it immediately, so you can just do this.sound.play and then the name of the sound you want to play. So now when Sonic collides with a ring, we can hear the related sound. Now let's add the hurt sound in the Sonic and Motobug collider logic. So in the game over logic within that handler, collider handler for this situation, we're going to play the hurt sound at the volume 0.5. And outside of that, so in the non-game over situation where we actually jump on a Motobug, then we're going to play the destroy sound and the hyper ring sound. So the destroy sound will tell the player that they have successfully destroyed a Motobug, and the hyper ring sound will notify them that they have received a higher score, a higher number of rings, basically. Now, if you play the game, you'll hear all the necessary sounds except for the ambience sound. So let's add it. So in our create method in our game scene, we're going to have a class variable called city ambience. And then we're going to add the sound city with a volume of 0.08. And then we can also specify the loop property, and we're going to make it loop indefinitely. And then immediately we play it. So this is one way you could do it. You could also, we're going to do it this way because later on we're going to need this city ambience class variable to stop the sound, because the sound will continue to play even if we transition over to the game over scene. So if you play the game, you're going to notice that this is an issue. So first, let's make the ambient sound slightly louder to 0.2 instead of 0.08. And then in the collider handler of Sonic and the Motobugs, in the game over logic, the if statement that takes care of that, we're gonna call, as soon as Sonic is dead, the city ambience sound, and we're gonna call the stop method of it so that it's going to stop before we move over to the game over scene. Now, one thing I've noticed is that this Sonic is dead property is actually useless. I don't think we have used it at all in this tutorial. So yeah, feel free to remove it. Now has come the final part of this tutorial, which is deployment. How do you get the game that is now fully complete in players' hands? For web games, it's publishing them on platforms like itch.io, which is a platform that allows you to publish games on the web or even downloadable games. And there are other platforms. So let's go with itch.io. I'm going to show you how to do it. First of all, in your code, create at the root of your source code, not the src folder, just at the root of the project, a vite.config.js file. And in that, first import a defined config from Vite, and then call the defined config function and pass to it an object with the base set to /. This is for the base to be relative. Otherwise, if you upload it to itch, it's going to expect a absolute path or something like that. So this is something I never truly understood exactly why we needed this, but it seems to be needed with Vite in order to have a deployment that actually works. Now in the terminal, run the command npm run build. You should notice that a dist folder was created. Now you can ignore the yellow message that appears. This isn't really relevant for games. This is mostly an optimization for websites. It's not really possible to have a 500 kilobyte game, especially with our assets. And now to preview your build, to make sure everything works, you run the npm run preview command. And then you can use the localhost link and see if it actually works. Now to publish the game on a platform like itch.io, you open your codebase, your project folder, and you zip the dist folder and then rename it to, for example, game.zip. Then you go on itch.io, and assuming you already have an account, and go to your dashboard and then create a new project, name it however you want, upload the files. Also in the kind of project section, set it to HTML, and then you can check a check mark which says this file will be played in the browser. And now you can set a couple of options, like make it mobile friendly, have a full screen button, and then hit the save and view page. And then if you go to your page, you can see the game running. I usually prefer, though, in the embed options, to just have a click to launch in full screen toggle instead of having a specific frame within the page. But this is up to you. That's it. Now that you have deployed the game, I hope you learned a thing or two about Phaser, and I'm hoping to see you in another tutorial. Thanks for watching. Bye.